Start with the question, number of sequences that satisfy the given sum condition. You are given an array of integer nums and an integer target. Return the number of non-empty subsequences of nums such that the sum of minimum and maximum element on it is less than or equal to target. Since the answer may be too large, return it in modulo 10 to the power 9 plus 7. Let's see how we are going to approach this problem. Let's see example 3. So we have an array 2, 3, 3, 4, 6, 7. So this array is already sorted. Okay, so this element becomes the minimum element and this becomes the maximum element. This is the maximum element here and this is the minimum element. Okay, so we can iterate from the smallest element I here and we can have j as the pointer pointing to the maximum element, right? So this gives us the maximum possible number for this minimum element that will give us the possible target which is less than or equal to the given target, right? So if we sum these two elements, 2 plus 7, we get 9 which is less than equal to 12, right, which is the target we had to create. So when we create this array, so any number which is to the previous of the max element can also be taken in the subsequence, right? Because 2 plus 6 would be 8, which would be less than 2 plus 7 in any case, right? And similarly for 2 plus 4, 2 plus 3 and 2 plus 3, right? So every possible element can either be present or not be present, and then we will get the subsequence that we want with the sum of the minimum and maximum elements would be less than equal to target always, as long as the minimum element is this, right? So let's see how many of the possible subsequences can be made. The first subsequence would be the whole array 2, 3, 3, 4, 6 and 7, right? We can remove this element and this will also remain the subsequence, required subsequence. We can remove this, also remains the same, next, next and next. So all of these elements have the choice either to take or not take, right? So same for this, same for this, same for this and same for this. Okay, so by using mathematics we can say that the possible number of subsequences that can be formed would be the number of elements, the greater elements that can be present in the array, right? So what is the number of elements? 1, 2, 3, 4, 5. Okay, so with this as the minimum element, we have 5 numbers that can be present in the subsequence as long as this stays the minimum element. Okay, so we can say that it has two choices, it has two choices, it has two choices, and it also has two choices and also has two choices. So 2 to the power of 5 becomes the number of arrays possible with 2 as the least element. Okay, so we have here 32 number of arrays will be possible, right? Next we increment our I pointer to the next element, right? So we get here 2, 3, 3, 4, 6 and 7. 4, 6 and 7. Okay, so we have our I as here and we have our J here, right? So as 3 plus 7 is less than equal to target, 3 plus 7 is less than equal to 12. So we can take or not take all of these elements. So all of these elements can form the subsequence, required subsequence. Okay, so how many of the subsequence would be made? 1, 2, 3, 4. We have 4 elements, so 2 to the power 4 subsequence, that is 16. Right, now we increment the pointer 3, 4, 6 and 7. So here is I and here is J, and 7 plus 3 again is less than equal to 12. So we can take all of these elements as a part of subsequence with 3 as the minimum element. So 3's position is going to be fixed and we can either take or not take all these elements. Okay, so we have 2 to the power 3 subsequences for that case, and this becomes 8. Okay, next we have 2, 3, 3, 4, 6, 7. We have I here and we have J here. 4 plus 7, as 7 is the maximum element, 4 is the minimum element, is still less than equal to 12, which is 11, and we can take both of these elements, either take or not take, to form the subsequence. Okay, so we get here 2 to the power 2 subsequences, which is 4. Now we move our I pointer 6 and 7. Okay, so we have our I pointer here and our J pointer here. Okay, so as we know that the minimum element would be 6 and the maximum element would be 7, so if we add these two we get 13, which is not less than equal to the target, which is 12. Okay, so we are going to decrement the J pointer. And why decrement the J pointer? Because decrementing the J pointer will make this, the max value, lower. Okay, so we can move towards the lower value, right? So the J pointer becomes here. Now we check the maximum element and the minimum element, both become 6. So 6 plus 6 is 12, which satisfies the condition of being less than equal to 12, right? So we can take this subsequence, and we don't have any more elements, only one possible subsequence can be there. So 2 to the power of 0, which gives us one subsequence, right? So when we add all of these subsequences, that is, we add here 32, and we add 16, then we add 8, then we add 4, and then we add 1, right? So we get 61 subsequences. Okay, so there are 61 possible subsequences possible for this. Okay, so I hope you understood the approach, how we are going to solve this problem. Okay, So the number one thing that we are going to do is sort the array. Okay, so and we I is equals to the 0th index, and we get j is equals to the n minus 1th index. We start from this. Okay, and the third thing we do is we have to calculate the powers of 2 that is going to be added in the value, and j would be the index which satisfies the condition nums of I plus nums of j be less than equal to target. Okay, so j is going to be that particular condition, so we have to decrement j as long as this condition is false. Okay, so we can get the value of j. Next we'll add 2 to the power of j minus I, which will give the number of elements present, right? Let's see how. So if we see here, we get 0, 1, 2, 3, 4 and 5. So how many elements are there in this case when 3 is the minimum element? We have 3, 4, 6 and 7. We can take or not take all these elements, right? So there are 5 elements. No, there are 4 elements, right? So how can we calculate? We have I here and j as 5, and we have I here as 1. So if we subtract j minus I, we get 5 minus 1 as 4. So we can calculate 2 to the power 4 as the number of subsequences possible. Okay, taking this as the minimum element. Okay, so that's how we are going to operate, and as we have to return the answer in modulo, so we are going to calculate it like that. We can see that here we have declared mod as 10 to the power 9 plus 7, that is the given value, right? And we sort here nums using the stl function sort. Now we have here power as the array in which we are going to calculate the powers of 2. Okay, so power of I is equals to power of I minus 1 to LL because we have to calculate it as long, right? And we modulo it. Now we have in I is equals to 0 and j is equals to nums of size minus 1. We have long answer is equals to 0, and while j is greater than equal to I, we are going to check whether nums of j plus nums of I is greater than target, and if it is greater than, we will decrement the value of j, and while j is greater than or equal to I, we are going to decrement. We are also going to check this. Okay, and if j is less than I, we are going to break, and we are going to add answer plus the power of 2 to the power j minus I, and we are going to modulo it, and we will increment I afterwards, and we return the answer. So I hope you understood the solution to this problem, and if you have any doubts, you can write it in the comment section. Thank you.